So the slope of a line, we talked about the slope of a line being part of the y equals mx plus b form, specifically the m, the coefficient of x in slope-intercept form that represents the slope of the line. Now the slope of a line, what it does is it measures the steepness of that line. Right, so if you think of a diagonal line kind of as a hill, you know, how steep is this hill? Is it easy to walk up, or is it going to be, you know, a little more tiring to walk up this hill, right? If a hill is, you know, not, you know, kind of relatively flat, or if it's, you know, a little more steep, the higher number is going to be this steeper line, right? You can kind of go with that rule for the most part. And there are, you know, whether it's positive or negative depends on the word higher or lower. But the way you refer that you'll see the slope of a line referred, a lot of times something colloquially known as rise over run. More in depth, notice the delta symbol is Greek for change, so change in y over change in x. But the most useful thing that you might see the slope of a line referred to is the formula, which is y2 minus y1 over x2 minus x1. And these all kind of mean the same thing, change in y over the change in the values of x. In general, the slope of a line comes in two different flavors. One of them is positive, the other one is negative. Right? Most of the time, when you see a positive slope, it's going to refer to a line generally looking like that, right? And again, the steepness is going to depend on the number. But if that number is positive, then you can kind of just expect a line to look like that. Again, going over to the upper right and also the lower left-hand side. Right? A negative slope is going to do the opposite. Right? If you were looking at this line from left to right, that means it's going to start on the upper left-hand side, go down to the lower right-hand side. Right? And that's the general main difference between a positive and negative numbered slope. So, but let's use this formula. Find the slope of the line between two numbers, negative 1, 1, 2 points, negative 1, 1, and negative 8, 6. Right, so what I like to do here is, if I'm given two separate ordered pairs, is to label them as x1, y1 and x2, y2. And which one you label x1, y1, x2, y2 doesn't matter as long as the same ordered pair is labeled 1 and 2. So our formula, once again, y2 minus y1 over x2 minus x1. We can plug in our numbers. y2 is going to be 6. Y1 is going to be 1. So on top, 6 minus 1. On the denominator, negative 8 minus negative 1. Remember, when you are plugging in negative numbers, use parentheses, right? Plugging in positive numbers most of the time won't matter. But generally speaking, right, more specifically actually, you should always be using parentheses to plug in numbers. So 6 minus 1 over negative 1 minus, negative 8 minus negative 1. So we're going to get 6 minus 1, which is 5. We're going to get negative 8 plus 1, which is equal to negative 7. So whether negative is on top or on bottom, it doesn't really matter, because that just means that this slope, this number, is a negative. That's negative 5 over 7. So let's take a look at really what the slope of a line means. Right here I have two, you saw me graph the two lines in the previous lines video. So let's graph these two lines. Y equals 2 over 5x plus 4 is the first one. And here's what we're going to do. First thing we're going to do, again, this is already in slope-intercept form. Let's identify our slope, which is equal to 2 over 5. Sorry about my iPad there. Kind of glitching on me. And the y-intercept is equal to an ordered pair of 0, 4. Again, that's read straight from this equation. So graphing a line using the slope-intercept form, first start with the y-intercept. 1, 2, 3, 4. From the origin, plot the ordered pair of 0, 4, which is our y-intercept. And from here, here's what we're going to do. We're going to use the slope of this line, 2 over 5. Now, a positive slope, which this is, means that you go up and right. This is the change in y over change in x. So from this ordered pair, not from the origin, but from the first ordered pair that we made, we're going to go up 2 units and to the right 5 units. And then put another ordered pair right over there. Again, so remember, from our starting point, which was the y-intercept, we went up 2 and we went 5 to the right. Right? And if you want to do more points, then you can continue on from the first point that you made. Up 2 and to the right 5. Again, that's 2 up and that's 5 to the right. And then you could put an ordered pair right there. So let's suppose that we didn't have all of this space over here. Or let's just suppose we didn't want to go up and to the right. Right? A positive slope means that you can do 2 separate movements, up and to the right or down and to the left. But the point is that if you're evaluating a positive slope, you have to do these combinations of movements, up and to the right or down and to the left. So down 2, 2, 3, 4, 5, 2, 3, 4, 5. 2 down, 5 left, right? Notice that what we're doing here is, even if we're moving up and to the right or down and to the left, we're putting all of these points in a straight line, right? But then we're going up 2, because that's the numerator. We're going to the left, or we're going to the right 5, because that's the denominator, all right? Whether it's up or down, it's this many spaces. Whether it's left or right, it's this many spaces. And that's the equation of this line. So let's look at y equals negative 4 over 3x minus 2. This one has a different y-intercept. It's 2 spaces below the origin, right? The y-intercept is located at 0, negative 2. The slope of this line is going to be negative 4 over 3. Right, so the main difference here, aside from the numbers being different, the main difference here is that this slope is a negative number. And while we saw a positive go up and to the right, we're going to see a negative go down and to the right. Notice that we are not reversing both up and right, we're just reversing one of them. If we reverse both of them, that gives us down and left. That is still a positive slope. So down and to the right, that means down this many units, and to the left, this many units. So let's go down 4 over here. 1, 2, 3, 4. And let's go to the right 3 over here. I should erase that. That point shouldn't be there because that's not a point. All right, so we went down 4 and we went to the right 3. Again, this is a negative slope. One of these movements is negative, the other one is positive, right? So if we think of going to the right as a positive, that means we went down, which is a negative. And that creates a negative number. Right? We don't really have any more space on the bottom here. So So if we want to continue along, let's also go up, which is positive, and left, which is negative. And again, this will create a negative numbered slope. So up 4 units, 1, 2, 3, 4. And to the left, 3 units. So notice that again, these points are still on the straight line. Let's do this again. Up 4 units, 1, 2, 3, 4. And to the left 3. That's 4 up, and that is 3 left. And once again, whether we are going down and to the right or up and to the left, this many spaces, we are putting all these points on a straight line. So let's go through one more problem here, which doesn't really involve graphing at all, but does involve utilizing all of this stuff. Write an equation of the line that goes through the points 5, -7, -1, -8. The equation of a line, remember, comes in y equals mx plus b, where the numbers are m and b. So in order to write the equation of a line, the main thing that you need to know is the slope, and you need to know a point that this line is going to intersect. On this problem here, we're given 2 points that the line has to intersect. Right, so that's given to us. Let's find the slope. Since we're given that this line has to go through 2 points, that means we can use our slope formula, y2 minus y1 divided by x2 minus x1. All right, this is our slope formula. -8 plus 7 divided by -1 plus -5. And that's going to equal -1 up top, -6 on bottom. Negative over negative reduces to a positive. So our slope is equal to a positive 1/6. So we know what the slope's going to be. We got that down. And this problem might say it has to be perpendicular to this line or parallel to this line. In that case, you would find the slope of the other line that's given. And if it's parallel, make it the same, the new one. Make the new slope, the new equation to have the same slope. Or if it's perpendicular, make the new equation to have the negative reciprocal slope, like we talked about in the previous lesson. This one is just giving us that it has to go through these points, though. So we have a slope that's equal to 1/6. And that means that y equals mx plus b is going to say, in some fashion, y equals 1/6x plus b. So we got to figure out what b is going to be, the y-intercept here. Since we were given, since we calculated the slope is equal to 1/6, we can plug that in, right? But look up top, we're given 2 ordered pairs. One of them says x equals 5 and y equals -7. That's the first ordered pair that we are given. We can also use the second ordered pair, but we only need to use one of them. So this means that this equation, -7, equals 1/6 times 5 plus b. We can plug in our x and y that we're given and create ourselves an equation to solve for b. Multiplying these fractions, 1/6 times 5/1 is going to be 5/6. And in order to solve for b, we can subtract 5/6 from both sides, right? This is a normal standard equation that we're isolating b. So off to the side over here, we're subtracting fractions. -7/1 minus 5/6, right? This is going to require a least common denominator of 6, which means that -7/1 is going to turn into a -42/6. And if we are to subtract -42 minus 5, that becomes -47, and the common denominator carries through. So b is equal to -47/6. Now it's important that you answer the question. Write an equation of the line. So the equation of the line is going to say y equals our slope 1 over 6 times x minus 47 over 6. This is the equation of the straight line that intersects the points of 5, -7 and -1, -8.